Hello everyone, welcome back to my YouTube channel. In this video, let me explain you about phasor diagrams for transformer on load. So in a previous video, I explained about practical transformer on no load and practical transformer on load. We can also call that as MMF balancing. So I explained about MMF balancing. So the continuous part of that is practical sorry, that is phasor diagrams for transformer on load. Okay, so these all I explained in a previous video, very simple concept. So if you want, I'll just brief about this practical transformer on load. So giving supply to the primary winding of the transformer that produces the alternating flux, you can call that as a main flux that is linking to the secondary winding. Secondary winding also produces its own flux, that is phi 2, which opposes the main flux. So due to that, what happened? It is started to disturbing the main flux. So to neutralize that flux produced by secondary winding, will be giving or else will be applying additional current to the primary winding of the transformer, that is I2 dash, which is having no load current and load current. That is I2 dash is responsible to neutralize the main flux produced by the primary winding by neglecting or else by reducing the flux which is produced by the secondary winding, so that the additional current I2 dash produces phi 2 dash that opposes the main flux, sorry, that opposes the flux that will be produced by the secondary winding. Hence, there is a MMF balancing happening in a secondary side N2 I2, in a primary side N2 I1 dash, sorry, I2 dash. We'll get I2 dash as a K into I2, and with the help of that, we'll be explaining this for different loads, that is for resistive load, inductive load, capacitive load. So I'll just explain in simple words. Flux, for this flux is a reference, and I naught will be getting with help of IC and IM. E1, E2 are which are in phase with each other, which always lagging the phi at an angle of 90 degree. For resistive load, I2 is in phase with the E2, and by adding this I2 dash and I naught, you'll get I1, because the primary current is having two components. One is no load current and the one is a load current, that is I2 dash. I2 dash is always anti-phase to the I2. By adding I naught and I2 dash, you'll get I1. And V1 and I1 angle is phi 1, and V1 and I naught angle is phi naught. For inductive load, I2 lags E2. For capacitive load, I2 leads E2. So with the help of that, let us go for the next concept, that is phasor diagrams for transformer on load. So before drawing the phasor diagram, we should know equivalent circuit diagram of transformer along with the resistors, okay, and reactances. So where there is a resistor, there is a loss. So that is called practical transformer. That is why you just observe, or else you just observe this phasor diagram, whereas it is having a V1, R1 and X1, which are resistances in primary winding and reactances in primary winding. You can see here various components. R1 is primary winding resistance, and similarly X1 is primary leakage reactance. You can see R2 is a secondary winding resistance, and X2 is secondary leakage reactance. ZL is nothing but load impedance. I1 is nothing but primary current. I2 is nothing but secondary current, that is nothing but current that will be flowing through the load. You can also call that as load current. So this primary current I1 is having two components. One is a no load current, other one is a full load current, that is I naught and I2 dash. Whereas this I naught is nothing but no load current, I2 dash is current nothing but load component of current decided by the load. That is nothing but if there is a inductive load, this lags V2. If there is a capacitive load, I2 dash or else I2, that will be leads V2. If there is a resistive load, I2 and V2 are in phase with each other. So you can see I2 dash is given by K into I2, where K is a transformer component, that is a transformation ratio that I explained in a previous video. So with the help of this, you can see now the primary, so you can see The primary voltage V1 and V2 you are writing. V1 it is having now three components. One is E1, V1 and E1. So this E1 and V1 which are always opposite to each other because of Lenz's law. So that minus E1, the induced EMF which opposes the V1 due to Lenz's law. Similarly, one more is drop across R1, that is nothing but I1 R1, and this drop which is always in phase with I1, you can see. And also one more is a drop across reactance. So this is always leading I1 by 90 degree. You just remember these points before doing the uh, phasor diagram. Similarly, you can see V1 how you are writing. So V1 is nothing but you are adding all these three minus C1 plus I1 R1 plus I1 X1. You can see you are taking I1 as a common, you will be getting minus C1 plus of I1 of R1 plus JX1. It is nothing but impedance. You will be writing it as minus E1 plus I1 into Z1. Similarly, how we are writing E2? So the secondary induced EMF is also having three components. One is a V2, you can see. Another one is drop across R2, drop across X2. Drop across R2 is always in phase with I2, drop across X2 is always leading I2 by 90 degree. So you can see E2 is given by adding all these three. You can see E2 is V2 plus I2 R2 plus I2 X2. So you want V2, so that V2 you are writing it as, you are sending everything this to the right side or left side. E2 minus I2 into R2 plus JX2, you will be having E2 minus I2 into Z2. So these you should remember. Okay. So now let us go for the phasor diagram for three different cases. So you can see three different cases. So first one is for resistive load and inductive load, capacitive load. So will we go for the resistive load first, R load. So before that, remember the key points. So V1 is having three components. One is minus E1 plus I1 R1 plus I1 X1. Similarly, E2 is having three components, that is V2 plus I2 R2 plus I2 X2. So with the help of this, you're writing V2 is nothing but E2 minus I2 R2 minus I2 X2. Okay, we'll be writing V2 and V1. Okay, so with the help of these equations, you can see V2 is minus E2 minus I2 Z2 minus I2 R2, you can write. Okay, so plus J1 X1 plus J minus J. So where there is a reactance, you are writing the J operator anyhow. So now steps. The first step is flux phi. To produce a phi, I naught is responsible. So that I naught and IM is responsible to produce flux phi. Similarly, IC and IM are perpendicular to each other. By adding these two, what you'll get? I naught. I naught. We'll be getting I naught here. Similarly, the induced EMFs E1 and E2 are in phase with each other. E1 and E2 are in phase with each other. And this E1 and E2 are lagging phi at an angle of 90 degree. So I will write the steps now. The first step is phi is reference. Second step is IM is in phase with phi and IC is quadrature with respect to IM. So that by adding IC and IM, you will get I naught. Okay. So once after knowing the I naught, you need to write I2 dash or else I1. I1 is given by I naught plus I2 dash. Whereas this I2 dash, I naught is having two components. One is IM and IC. Keep that in your mind. So I2 dash is nothing but always it is antiphase of, this is antiphase of I2. That is opposite to I2 is I2 dash. this equation. The third step is E1 and E2 are in phase, and lags phi by 90 degree. These three steps you have now. So now V2, assume the direction of V2 somewhere that will be less than E2 or else greater than E2. So now V2 is greater than E2, so I am assuming the direction of V2. Okay, hence the angle between V2 and E2 is phi 2, whatever you write. So now E1. So what is the aim of this particular phasor diagram? You need to draw the phasor diagram for these two equations, that is V1 and V2, or else E1 and V2. With the help of this E1, how will write? E1, no, V1 only you need to write. So first you consider this equation. To write the V1, you need to know minus E1, but you have plus E1. So antiphase of this is minus E1. This is your minus E1. Okay, you got minus E1 plus I1 R1. I1 I don't know. First I need to get I1. What is I1 here? I0 plus I2 dash. So I2 dash you should get I2 dash. If you want to get to know I2 dash means you should get the value of I2. So I2 is in phase with V2 now because the load is resistive load. So second equation, you need to know both V2 equation or else E2. E2 how will get? V2 plus I2R2 plus I2X2. V2 have, if you want to get I2R2, draw a line which is parallel to I2 from the tip of V2, you can get I2R2. And from the tip of I2R2, draw a perpendicular line, you'll get I2X2. So you can see if you add V2 plus I2R2 plus I2X2, you'll get E2. This is nothing but your impedance Z2. So now we got I2, draw a line which is anti-phase to I2 that to get the value of I2 dash. So now this is I2 dash. Sorry, I2 dash. Once after getting the value of I2 dash, now you try to write equation V1. V1 is minus E1, minus E1 you have. Then you need to write I1 R1. To get the I1 R1 from the tip of minus E1, draw a line which is parallel to I1. Before that, you need to get the value of I1. I1 how will get? By adding this I2 dash and I0 will get I1. So from the tip of I2 dash, draw a line which is parallel to I0. Similarly, from the tip of I0, draw a line which is parallel to I2 dash. Somewhere it will intersect. This is your I1. So now minus E1. If you want to get I1 R1, from the tip of minus E1, draw a line which is parallel to I1. You will get I1 R1. From the tip of I1 R1, draw a line which is perpendicular to the I1 R1 to get I1 X1. So now minus E1 plus I1 R1 plus I1 X1. If you add these three, you will get V1. This is the phasor diagram. Okay. So like that you should remember. So now we can see here the phasor diagram. The first point, phi is reference. Second point, you should get the value of I0, whereas I0 is given by Im plus Ic. Okay. Third point, E1 and E2 are in phase. E1 and E2 are in phase and lags phi by 90 degree. Fourth point, give direction of V2 and I2 is in phase with the V2, in phase to V2 because the load is resistive load, R load. Okay. Next to get the value of E2 equation, you know that E2 is given by V2 plus I2R2 plus I2X2. Therefore, you can see from the tip of V2 draw a line which is parallel to I2. Then from the tip of I2R2 line, draw a line which is perpendicular then you'll get E2. E2 is given by V2 plus I2R2 plus I2X2. And I2, draw a line which is antiphase. Next fifth point is I2 dash, antiphase to I2, antiphase to I2. Then you add I0 and I2 dash to get I1. You'll get the value of I1. So next you get minus E1. Minus E1, that is antiphase of E1. Antiphase of, sorry, that is antiphase of E1. Next, from the tip of E1, draw a line which is parallel to I1. Then from the tip of I1R1, draw a line which is perpendicular to get I1X1. Then minus E1 plus I1R1 plus I1X1, you will get V1. This is I1Z1. The same procedure you are applying for all the another two loads, that is inductive load and capacitive load, to get the same equation, but the direction of I2. You can observe now. For before that, you can see here angle between V1 and I1 is phi 1. Everything they are explaining here with the help of phasor diagram. You can take the screenshot for this. So now the same thing you are doing for the inductive load. The difference you can see, you are giving the direction of V2. Here I2 is not in phase with a V2. I2 is lagging V2 at an angle of phi 2 because inductive load. Rest of the procedure is same. Okay. Similarly, capacitive load, this I2 is leading the V2 at an angle of phi 2. See, V2 direction you are given, but I2 is leading the V2 at an angle of phi 2. Rest of the procedure that will be same for phasor diagrams of transformer on load. So if you are having any doubts regarding this, you can feel free to write in a comment box. So I think one procedure is enough. If you want means I'll explain in another video, or else just brief here only. The same thing, the reference is phi, and by adding I0 and by adding IM and IC, this is IM and IC, you'll get the value of I0. Then E1, E2 are in phase with each other, and these are lagging the phi at an angle of 90 degree. Okay. Then giving the direction of V2, the load is inductive load, so that I2 lags V2 at an angle of phi 2. Antiphase of I2 will get I2 dash. Adding I0 and I2 dash, you'll get I1. From the tip of V2, draw a line which is parallel to I2 to get I2R2. From the tip of I2R2, draw a line which is perpendicular to get I2X2. Then V2 plus I2R2 plus I2X2 will get the value of E2. Similarly, once after knowing the value of I1, get minus E1, that is antiphase of E1. From the tip of minus E1, draw a line which is parallel to I1 to get I1R1. Then from the tip of I1R1, get a perpendicular line to get I1X1. Then you add minus E1 plus I1R1 plus I1X1, you'll get the value of V1. I hope you are getting. Similarly, for capacitive load, phi is a reference, I0 you are getting, E1, E2 are in phase, and this will be lagging the phi at an angle of 90 degree. Then giving the direction of V2 here. So now the load is capacitive load, so that I2 leads V2 at an angle of phi 2. Then to get the value of E2, from the tip of V2, draw a line which is parallel to I2 to get I2R2. Again perpendicular line to get I2X2. Add this V2I plus I2R2 plus I2Z2 or else I2X2. You'll get E2. Once after knowing the I2, get I2 dash. Add I0 and I2 dash. You'll get I1. Get minus C1, that is antiphase of E1. Then from the tip of minus E1, draw a line which is parallel to I1 to get I1R1. From the tip of I1R1, get a perpendicular line, that is I1X1. Then add minus E1 plus I1R1 plus I1X1, you'll get the value of V1. This is the procedure. So if you're having any doubts regarding this particular phasor diagram, you can feel free to write in the comment box. I hope you're getting this step by step I explained. So it's a very important concept from examination point of view also. So practice it well. If you really like this video, don't forget to subscribe, share maximum. Thank you so much. Have a nice day. Keep learning.